welcome to this ATCC webinar. This is hosted by Schub, one of our members for the IT committee. The webinar is entitled Stop Wasting Money on the Cloud, which it makes a lot of sense. I'm Facundo Navarro. I'm your host, the president of the IT committee and the moderator for this session. So thank you for joining all today. Before we dive into our webinar topic, let me take a moment to introduce ourselves and give a brief overview and of who we are and what we do. The ATCC Argentina-Texas Chamber of Commerce is an independent non-profit voluntary membership association founded in 2016 with the objective of promoting invest trade education and networking opportunities between Texas and Argentina by acting as a catalyst for innovative, ethical, and productive business relationships. The ATCC also offers support and resources, helping companies navigate cultural difference and overcoming the challenge associated with doing business in a foreign country. The Chamber is dedicated to fostering a strong economic relationship between Argentina and Texas and promoting growth and prosperity for both regions. I would like to express our gratitude to our corporate members for the continued support to the Chamber. They are Pan American Energy, Duralite, Globant, and PCR, and AESA, Marval, O'Farrell, Marial, Mayer, Brown, Practica, ProShell, and Q Advance. These are our corporate members that always sponsoring and helping us running out these webinars. Okay, so for this webinar, the purpose is in this session, we will provide to the audience with an impartial and insightful perspective on the cloud. And our goal is to present a balanced view, steering clearly of any sales pitches and instead offering an accurate information and practical insights for cost saving through the cloud implementation. So let me introduce you to our speaker for today, Luis Vinay, founder and CEO of Schub. Luis has a vast experience in leading teams of professionals dedicated to the transformation business goals into cutting-edge cloud solutions. His latest venture, Schub, represents the culmination of valuable lessons learned from previous experience applying this knowledge. Luis and his team have built a dynamic and forward-thinking company, and this is something this is something else I want to add. Schub company specialize in cloud. So, guys, you have the guy here to ask those questions that sometimes can be hard to answer. Okay, so take advantage of Luis here. Luis, anything that you want to add from your presentation?
I just wanted to thank the Argentina-Texas Chamber for the opportunity to allow us to share our experiences. And no, I don't have much else to say. Your presentation was pretty flawless. Thank you, Facundo.
Awesome. Luis, the stage is all yours. So let's get ready to rumble and see you back for Q&As.
Okay, so let's get started. Well, I'm that guy. That's not important.
Luis, one more comment. I want to let the audience know we record our webinars because later on you will find it on the ATCC page on YouTube. So please be aware this is being recorded. Okay, Luis, sorry, thank you. Go ahead.
Yeah, don't worry. Okay, so first thing I want to start with is making sure that we are on the same page. What is the objective of this webinar? I'm not going to go into any kind of absolute detail or technical depth on the matters I'm going to discuss. This is just like an overview to share you the experiences that we accumulate over the years on the kind of things that can help you make or break your experience going to the cloud. Perhaps if there is enough interest, we can do another follow-up webinar session with any kind of technical subject in particular. But I don't want to Uh, there's so much to talk that is non-technical to discuss about saving money on the cloud that it doesn't make sense for us to go into detail, because otherwise we would be hours here. Okay, this is the agenda for today. And we have a lot of things to discuss, so let's get going. So the first thing I want to start is that this is very important. If you read the cloud services value proposition, you will see that it says mainly two things. That is, pay as you go and on demand. And those are perhaps the most important thing that you have to keep in mind when you're thinking on going to the cloud. That is a on-demand pay-as-you-go service. And if you fail to keep that in mind, well, you're in for a bad time on the cloud, because if you think it and you design everything like you have all the resources all the time, it's going to be very expensive for you. So let's start with the good of Clint, and he knows better. So let's start with the good. Okay, when is usually a good idea to go to the cloud? Well, you have a team that allows you to take advantage of the cloud resources and have the knowledge to have. But this might sound obvious, but it's not. If you don't have a team that's actually good and understand and experience working with cloud environments, basically it's going to be very expensive for you. and you will see a lot of examples during this presentation. So you also have you can leverage the strong points and the specific technologies that the cloud can provide, and whatever you're going to run there it's capable of running on the cloud. Also, you have you can leverage the global reach. Is also a very good start. We are going to see some examples of that also in the future. And also, if you think about the kind of demand that you're going to run on the cloud, you will see that it goes very closely with what I just mentioned, that it's on demand, and and you can take advantage of that. So if you are, for example, in retail, and you it's the best example on what variable demand or seasonal demand is. For example, if you are a retail e-commerce, you will have most of the year like a flat line of of requirements, but then you will have dates like Mother's Day, Father's Day, Black Friday, Cyber Monday, the holiday season. Your demand will explode, and taking advantage of the cloud for coping with that demand on those specific dates, it's one of the greatest things that you can explode, in one of the greatest reasons to go to the cloud. Also, there are other group of reasons, perhaps maybe more business side or more business related, that makes a good idea to go to the cloud. And for example, you have some on-premise capacity, but let's say that you have a new client that asks you for some specific certification that your data center must comply. I don't know, maybe it doesn't have enough lines in the certifications. Therefore, you might end up having a contract breach, and that kind of things can get expensive. Or also, it's also a very good idea going to the cloud when your product is young and you don't have to do all the upfront investment of purchasing a data center or purchasing all the infrastructure that you might need to serve your clients or your possible clients. And also, there are some regulatory requirements that you need to comply. For example, if you have a workload that serves European Union citizens, and for some reason, you ask those European Union citizens to leave personal information, name, address, and that kind of things, GDPR forces you to save all that information. You have to store all that information within the borders of the European Union. So if you are an international corporation and you are serving you citizens, and you're saving that information, let's say in the US, you are risking yourself to a demand or a fine from the European Union. Those tend to not to be cheap. Okay, so when it's a bad idea going to the cloud. So let's start with some examples. Your application, whatever you want to run in the cloud, is legacy and it's monolithic, and it grows vertically. Later on, I'm gonna talk a little bit more about why it's a bad idea and how expensive it can get for a application to grow vertically. And also, if you have high connectivity cost, you have poor connectivity, or you have latency sensitive applications. For example, the Argentina-Texas chamber, a lot of the members are in the oil and gas, and those guys understand exactly what I mean. If you have a remote location, having connectivity to those locations might be either expensive or impractical, or I don't want to say impossible, but they could be really, really expensive. And if you base all the operation of those remote sites on cloud applications that are that need a good connectivity, fast connectivity, and a very responsive connectivity, you are in for a bad time, and you're going to have a lot of complaints. So more reasons to think twice before going to the cloud. You don't have a team that has this experience to manage properly cloud. That can be very expensive. Again, you have regulatory concerns that, for example, the easiest example I can give you is, imagine that you are a hospital and you are US based. There is a law in the United States called the HIPAA. That's basically the health that regulates the hospitals and regulates how do you manage certain things, like, for example, patients' medical history and data. What HIPAA doesn't allow you is to put that information outside the hospital. You cannot put patient information on the cloud. If you do something like that, again, you're exposing yourself to a very, very expensive lawsuit. Also, if you already made a huge investment or a big investment in your IT infrastructure, and your IT infrastructure is adequate for what you're doing, perhaps it's not the time to think on going to the cloud. Perhaps if you made the investment, you perhaps can start thinking on going to the cloud, but yeah, it doesn't make sense to make a huge investment and then go into the cloud. Also, if you have unsupported platforms, for example, I know, maybe you have a mainframe and you want to move that workload to the cloud, well, it's going to be a little bit complicated. So we already talked a little bit about the good, we talk about the bad, and now we're going to talk about the ugly. This is a little bit opinionated, but I have a lot of facts to back this up. If anyone, there's a lot of vendors who are going to hate me for saying this, but lift and shift, it's a hideous idea to go to the cloud. And I'm sorry, but I'm being really, really honest. And we, Schub as a company, can do this kind of projects. And there are very few instances where you want to do lift and shift. So, but before I go into that, let me explain you what lift and shift is. So let's imagine that you have these workloads, and what you do is basically you grab all that as it is. Usually those should in nowadays computer environments, all that is usually virtual machines. So you grab all those virtual machines without doing anything. You throw them into the cloud, and that's usually it's very easy and very fast, especially for the provider, to get that project completed. But it's very it tends to be very expensive, and it's kind of a lazy way of going to the cloud. Again, there are some very good business cases for lift and shift applied from on-premise to the cloud. let's imagine that blue box. It's a workload. It's an application that people in Europe consumes, and this building is in the United States. So you don't want to do that because it might be you might be infringing GDPR. So what you do is you grab that workload and you put it in a data center, let's say an AWS data center in Dublin or in Frankfurt, and done. You are covered and you're not having a problem. Those are the kind of uses that you might, the kind of circumstances might be acceptable to do lift and shift. But let's go back one step and think a little bit about the kind of workloads and how workloads are thought when you put them into an on-premises or in a data center. Basically, everything that runs in a data center runs 24/7. You don't shut that down. And that goes exactly against what I said at the beginning, where you want to, when you go to the cloud, you want to be on demand, right? So if you grab a workload that is designed to run 24/7, where in the planning, when you plan for resources on a data center, you usually plan for let's say 3 year. It's a very usual term to plan for resources. So imagine that a dog barking in my street. Thank you. Sorry. Okay. So when you grab a workload that is designed to run 24/7, when it's over provision, because in a data center, buying 1 gig, 4 gigs, 8 gigs more for a server is not a great expense, because I don't know what is $1,000, $2,000 for something that you're gonna take advantage for 3 years. It's a pretty good deal. But on the cloud, that could be very, very expensive. And also, there's another problem with the workloads that you put on premises, that you are not, since they are designed to run 24/7, you cannot just shut it down. Nothing in a data center gets shut down, because usually hardware failures occur when you turn on the servers. Power supplies blow up, this hardware blows up when you turn it on. So everything is turned on all the time, always, until you decommission, if you can. So imagine putting something that is designed to not be ever turned off in an environment that, without any notice, the resource might disappear. Well, it's a recipe for disaster. And again, the same thing. You end up having to use a lot of bigger instances, which are exponentially more expensive. And again, if you have to grow an application that's not designed, or it wasn't thought to run on the cloud, and taking advantage of the possibility of growing or horizontally, you will have to grow it vertically. Again, very expensive. So yeah, and this graphic is very telling about how expensive can it get. You see, from nano to micro to small to medium to large, and to 2x large, the prices doubles every time you go up one size on the virtual machine or the instance that you're running on the cloud. And the price, it gets exponentially more expensive. So micro costs us twice as much as nano. And this value that you hear, it has a 15 and 20 here, that's the cost per minute. This is not a figure speech or an example figure that I just made up. These are numbers from AWS. The T4G 2 extra large costs $16.5 per minute, and the T3 2x large costs around 20 per minute. So imagine if you have to grow this, how expensive. There are more expensive instances that cost thousands of dollars per hour. You can grow, but it's gonna be, you're gonna hurt. So basically, this is why a bad idea. You move things to a more expensive place, and you don't leverage any of the advantages of the cloud. Okay. Now, over the years, I've seen a lot of things going wrong with with the cloud on the cost. And I'm gonna share some of those experiences, hoping that you can avoid them. And again, these are the kind of things that make your life very miserable when you see the billing at the end of the month. So let me give you some examples of problems that might occur that in a data center are not a problem. So maybe someone that comes from the data center world, from a on-premise environment, won't even think about it. Limitless storage. In a cloud environment, it's not impossible to have a volume or a repository for files that can grow without limit. And the same way the repository or the file system grows without limit, the build follows suit. And the more you grow, the more expensive that it gets. And let me give you a practical example that we've seen in the past. Imagine that you have a Unix or a Linux server that has some kind of fault. It doesn't matter which. And someone from IT goes into the machine and grabs a few logs and puts them to be very verbose. So a lot of information is being thrown out to the disk every millisecond. So they can capture, or they are capturing packages and they're dumping the data packages, the captured data packets on the disk. And they forget to turn that off. Well, that goes very, very bad. And the worst can happen in a server on a data center is that it fills the disk and you get a alarm that the disk is filling. Well, no such thing happens when you have limitless storage on the cloud. In the same spirit, you have uncontrolled autoscaling. Again, the cloud is amazing because it's flexible. It will grow as much as you can afford, basically, and even it can grow more than you can afford. But basically, you have autoscaling to cope with the grow on demand. And someone decides to do a denial of service against your website. What happened is the autoscaling feature of, let's say, Amazon, it start to get more and more machines online to cope with that additional workload. Well, you can imagine where all those goes. Again, a big source of the previous two problems can be catched if you have billing alarms. So not having billing alarms, that it's basically that it says, oh, you went over X amount of money. You get an email letting you know you are spending more than you said that you wanted to spend. Here is an alarm. So if you don't have billing alarms, things can go bad very quickly. At least you will catch a lot of problems before they get extremely expensive. Okay, again, untrained engineers, I'm not trying to be an asshole here, but having untrained engineers with full access to the cloud can be very expensive because they can, without inadvertently known, creating very expensive. For example, it could be perfectly acceptable to create a virtual machine with 8 processors and 32 gigs of memory in your on-premise virtualization environment. But if you do that in a cloud environment, you will be spending, I should have get the number, but you're going to be spending like $100 per minute, or you will be in the vicinity of thousands of dollars per day if that person leaves that machine on the weekend, right? Think that it's perfectly acceptable for an on-premise environment where the money, it's the infrastructure is already there, and it's there for people to use. But on a cloud environment, again, it can get expensive very quickly. When you have bad automation, so automation is amazing because you click a button and a whole lot of infrastructure gets created automatically. Things get deployed, load balancers, server, Kubernetes clusters, database. In you see things being created and everything being connected, and you can access it. It's beautiful. It's beautiful. But let's imagine that you run the test that you wanted, and then you remove the pipeline to create that, and all that infrastructure stay there. And next day you want to do another test, so you fire up that again, and it creates another set of exactly all that: load balancer, databases, Kubernetes cluster, all that. And again, you can see where I'm going with that. And a little less problematic, but it can be expensive as well, as if you choose the wrong region. For example, the most telling example I can give you is Virginia. It's one of the cheapest AWS regions that you can choose. And on the other side of the spectrum, you have Sao Paulo. So let's say that you make your you budget a cluster of whatever, and you budget everything with Virginia numbers, and then you realize that you have to move it to Sao Paulo. You will find that the bill is going to be at least twice as big. That not even getting into the subject that on Sao Paulo there are features that you might not have, but that's a different problem. This one, it's a huge one. Let's say that you have two deployments on cloud on the same cloud provider. Let's say you have one in, I don't know, maybe Virginia, and the other in, I don't know, Ohio, right? And the way you connect that is you create a VPN, and like you always did, VPN, internet, everything, it's hunky-dory. It's not. When you send traffic over the internet, cloud providers tend not to like that, especially, and it's very expensive. For example, Amazon provides you what's called VPCs, which is the way they have to connect their sites using their own private connections, which are basically free or a lot less expensive. You still have a cap on the amount of traffic you can move, but that's a different problem. But if you do it on the internet, let me give you an example. You will be paying 3 times. You can end up paying up to 3 times of what you should be paying for that connection, because you are putting you are transmitting information from one side to the other on the internet, and all that traffic goes through load balancer, and if you have WAF enabled on AWS, which is basically a packet inspection feature of AWS, you will be paying for the internet traffic. You will be paying for the traffic that goes also through the load balancer, and you will be paying for the traffic that is analyzed by WAF. So if you need to interconnect 2 regions, use VPCs, and you're going to save a lot of money. Okay, so we left kind of the bad things in the past. Let's talk about how you can actually start saving money. And the first thing is not technical. So the first thing you should do if you want to save money in general, but especially in the cloud, is to follow best practices. Not sending traffic over the internet is a best practice, and it can save you a lot of money. But also, it's a very good processes will save you money, and I'm going to give you a lot of examples, and I'm very adamant about this. And I've seen many times over how bad processes will cost you money. Let me give you a couple of examples when not following good practices and not having good processes will cost you a lot of money. Have you ever heard of data breaches? Have you ever heard of old software not being updated, has security holes and ransomware? Well, that's one of the problems that you might not have if you have good processes and follow good practices, which are update your bloody software. Don't be don't be lazy. And also, you can lose a lot of. Uh, it can be very expensive on the PR side. It can be very expensive on your image. Let's say that you are a respectable company, and then you have some exposure or you have a data breach, uh, and all of a sudden all your clients start to lose confidence in you. It's going to be very, very expensive to regain that status that you usually have because some idiot forgot to that he needed to use a version of NGNX that was not 10 years old and doesn't have a hole like this, or didn't use TLS 110. Okay, so moving on. Okay, let's start with some good practices for the cloud. Again, the cloud, it's something that's flexible, it's adaptable. Automation, it's a must. Preferably automation as code, infrastructure as code. So if you have processes, you can create automation out of those processes, and those processes should go to something like change control. Again, if you have processes, change control management software like Git, which is the industry standard. If you don't know what Git is, you should give it a look. It's the industry standard for a reason. So with these three things, what you can achieve is is consistency, repeatability, and accountability. I don't want to extend too much into that, but having all those three things is something that you want. Again, since you have repeatability, you have consistency, you can allow yourselves to test often. So the more you test, the more sure you have that for example, your infrastructure will withstand. For example, what you can test is you can create a new set of infrastructure and you try to get to deny of service that infrastructure and see how it responds. If you don't have automation, create all that by hand, it's not going to be reliable because you cannot be 100% sure that what you did is exactly the same what you have in production. So if you use automation, you know what you have in production, is you can reproduce and you can blow it up and you can understand the limits of that infrastructure that you are deploying. That's one of the way that we test to fine tune, for example, the auto scaling. We create infrastructure, we stress test it, we see where it breaks, and we know where it breaks, and we inform the clients, hey, yeah, the infrastructure breaks here. Is this good for you? Oh, no, I can do with a little less. So we can dial that down, dial the infrastructure down, retest. So you can see how that kind of thing can save you money in the long term. And it's a lot less work automating infrastructure, deploying, testing, than doing all that by hand. And you would want to do that because it's fun. Again, and since you don't do things manually, you will naturally remove all stuff from your accounts, AWS cloud account or Google, whatever. And this is very important because if you remove things that you have laying around in your account, you will be paying for that and you don't need it. Even if it's, I don't know, if you have load balancer that has nothing connected to them, you will still pay for that. And you say, oh, but there's no traffic. Yes, there's no traffic, but you're still going to pay for that. So having a good cleanup culture, it's good practice. Disaster recovery. Again, if you have automation, you have the processes, you can test that. Tearing all the infrastructure down and bringing it back, you can do it. And you can be sure that what you're doing to save your information, and especially nowadays, when you have to clients, when you start to serve bigger clients, they want to know if they are going to integrate you into their processes. They want to know that you are reliable. And if something happens, you can be back up running again in X amount of time. That's a different conversation. So SOC 2 and many other quality and certifications will require for you to have disaster recovery and test for that. Okay, again, remember provisional alarms? Well, these set provisional alarms and budget alarms are two different things. Provisional alarms will send a notification when something is getting created on a account, which it's not it doesn't mean it's going to be a problem, but you can set up alarms for, let's say, someone creates a piece of infrastructure in a region that they shouldn't, or someone creates a piece of infrastructure without using automation. There are a couple of things that you can do that are very important. So I know someone that it's doing something they shouldn't do it. I'm not saying that people do it on purpose, but sometimes you don't have the right information and you do it wrong. You catch it early, you solve yourself a problem before it's actually a problem. All right. Good. So these savings are, again, not exactly technical way of saving money, but they are basically what you're going to do is you're going to make the life of people using the infrastructure very happy. And for example, a couple of things that you could do is when you set up, let's say that you have an infrastructure team and you have a group of developers, right? And those two teams are in different time zones. It's not unusual to have a developer team in the United States time zone and have a dev team in India or Eastern Europe or even China, right? So if you have good processes, you have documented, you create a good automation, you end up having continuous integration, continuous deployment pipelines that those teams can use without having to ask nothing to the infrastructure teams, right? So they don't depend from them. So they can do all the development and the testing by themselves. Therefore, there's the lead time between a decision and going to production, getting things live. It's much it's faster. Also, when this kind of thing happens, dev teams usually are the ones that depend on the infrastructure guys. Stop seeing the infrastructure guys as their enemies, or at least they stop seeing those guys as the guys that bring back news and get their objectives that don't help them to be effective. And also, this is very important. And I think I can see Facundo smiling right now. So if you do automated testing, this is extremely important, because if you have a good pipelines, you have independence of your team, and you integrate all those testing into the workflow for the dev teams to take advantage of, you will save a lot of money. Let me give you an example. How many times you see that code get stolen and published on the internet, and that code contains API tokens that are never going to be revoked because no one knows they are there. You have user password or proprietary information about your internal network. If you have a good QA testing that examines the code, you can catch all that before it even gets to the repository. So if the code gets stolen from the repository, you are completely sure that you don't have that kind of things there. Good. Again, and you foster innovation. I already mentioned that. Okay, let's talk about a little bit the kind of things that you can leverage with good practices on the technical side. Okay, reserve instances. Remember that I told you that one of the greatest things about the cloud services is that you pay as you go. Well, pay as you go is great, but if you pay in advance, it's even greater. So if you if you remember that I mentioned that we tested for the infrastructure to see how much punishment it can take and how many resources we need to serve that infrastructure. When you have that figure, what you can do is say, okay, I know that the minimal amount of infrastructure I need is this. So what I'm going to do is I'm going to pay in advance for a year of that, and I'm going to be saving 70% of the cost. That's what more or less Amazon is willing to give you if you reserve instances in advance that are with a year. If you can do it a little bit less, and the less you do it, the less the smaller the discount is. But using reserved instances, it's pretty much, if you are good at what you do and you can calculate how much you're going to need and you reserve it, you're going to save a lot of money. We try to do that for our clients. Also, this is for instance, I love spot instances because it's like gambling without actually gambling. This is a feature that is only in AWS, which is the following. AWS as the big company is, it also has a surplus resources, right? So the way they try to eliminate that idle resources is to offer you the possibility to bid for that idle space, and it is a bid. It's actually a bid. So let me tell you how it works. Let's say that you have an infrastructure that can cope. You have a good infrastructure that is cloud native. Therefore, if instances come up and down, disappear, and all that, your infrastructure can handle that. So what you do say, okay, I'm going to use for this part of infrastructure, I'm going to use the spot instances. So you go and you say, okay, I need a whatever large instance I need for handle with this with this workload, and I'm willing to pay this amount of money. And then Amazon will contrast your requirement for that instance on that availability zone on that region, and will compare it to the rest of the bids that you have. If your bid it's higher and it has the capacity available, it will grant you the instance and you will be able to use it. But if your bid, if you get outbidded, it will destroy immediately this and give it to someone else. But this can be used to greater effect if you are good enough at tuning the number that you use to bid. There is a sweet spot where you can lose some, gain some, but let's say that you need 10 instances. Well, depending on the bid, you might lose a few, then they come back together. And if let's imagine that you have to process you have to batch process something, and if you can do it for, let's say, 50% of the money, perhaps making the process a little bit slower, it's not a big loss, and you can actually save a lot of money. So spot instances are great for that kind of things. Again, it's cloud infrastructure, it's cloud native, you can shut things down. So let's imagine that you have your dev team, it's works from 9 to 5, and no one else is needing the infrastructure that team needs from 9 to 5. 5:30, you shut down everything. 8:30 next day, you bring all that together and you save a lot of money. That's great. That's one great thing of saving money by scheduling infrastructure ramp downs. Destroy. Again, the same. You see, there's a like a recurring theme here. Cloud is flexible. You don't pay for what you don't need. Destroy what you don't need when you don't need it. Again, remember the example I give you about VPC peering, not using the open internet traffic. And finally, well, no, finally, the Lambda functions are great, but you should not serve all your workloads with Lambda functions, because those get very expensive again very quickly. The Lambda functions are great for doing small things. right? You have a small thing that you need to do. You create a Lambda function that gets triggered when there is an event. That function, that piece of automation runs, does its thing, and then it disappears. But you should not have Lambda. You should not run services using Lambda function because they get a lot more expensive than, say, deploying Kubernetes. Yes, deploying Kubernetes, it's the technical complexity and the initial investment on time. You need a team that can actually do it. It's much greater than perhaps doing other things like ECS, for example, or maybe doing some other kind of deployments. But once you went you went through the threshold of making Kubernetes worth your time, you should do it, because Kubernetes, it's a platform that gives you a lot of tools that otherwise you wouldn't have. For example, if you deploy your own Kubernetes cluster, you gain the possibility to run that same automation, that same cluster in a different cloud provider. And it gives you a lot of observability tools that you otherwise don't have. It gives you a lot of fine-tune control over how the cluster behaves, and you can have a lot of tuning capability of how you deploy that cluster. So once you reach a certain level of maturity deploying your own Kubernetes cluster, it's a great thing to do. Okay. Now we are getting to the end of the presentation. I hope you're not all bored to death with me talking all this long. But let me, in this way, with this part of the final part of the conversation of the presentation, I wanted to share a experience that is very recent. This is an experience that it's from last year. We have a client. I cannot give any more details than I'm going to give you because NDAs, but this is a client that provides a service to retail. They have a solution that it's an API, so they charge by it's a suggestion engine. Let's say that you are major sport brand, and you have your e-commerce and you want to sell a t-shirt to someone, that someone goes and selects the t-shirt, and below the t-shirt you have a lot of other items that are related. So my clients, it's they provide the engine for those suggestions to appear. It's an AI trained model and it's basically an API, and they charge for each one of the suggestions that appear on the website that gets rendered. So that's the context. So the last year, so it was 2021. In 2021, during the holiday season, we experienced some problems with the workloads, and we experienced some instabilities with the service that made the holiday season for our company to not be as good as it could have been. There was some we lost the possibility of showing more suggestions, right? So we started the process after the holiday season ended, a process very lengthy, where we worked together with the dev team on planning a lot of changes in the infrastructure, and also some of the to leverage some of those gains, those potential gains with the infrastructure. Also, changes to the application had to be done. So what did we actually do? Basically, what we did is we generated a new automation. We refactored the way we manage resources. Again, leveraging new technologies, leveraging things that Kubernetes offered us. So we we managed resources on our way. We did a complete refactor for that. That was much more effective and led us to a lot of savings. Again, we did a huge work to understand where things going on. Kubernetes was key because we apply a lot of observability tools that gave us a lot of insight on what was going on with the cluster and why certain things were behaving not the way we wanted, and we were able to address all that. Some things were directly things that we could do by ourselves on infrastructure. Some other required changes to the application. But again, we improved the way the cluster was growing and shrinking back to have it to behave more like our client decided. We see that we could have improved that. And also, very important, we reduced a lot the average size of the instances that we've been using. Again, we saved a lot of money. I'm going to show you some numbers now. And also, some part of the application were using internet traffic to connect to databases, and we changed that, and we moved all that traffic into the VPC, and that alone represented a 25% reduction in the monthly bill automatically. Well, it was not automatic, but yeah. So let me show you this graphic. So on dark purple, what you can see, it's the expenditure on infrastructure. We started the process in July, right? And we rolled over those changes that we've been working on, the first one in July, and we left some of the legacy infrastructure to be able to do kind of A/B testing. So that's why it's still a little bit high. And then with September, October, and we did everything that we could have done, and we froze things. I think it was in October, but then in November you cannot change anything, and we had Black Friday, and you can see there how big the difference is now between the expenditure infrastructure and the amount of requests that we can serve. And you can see that even after the Black Friday, the infrastructure behaves more or less the same. So it's a very predictable and it's very lean infrastructure. This is practically, it doesn't change much because we more or less hit the minimum amount of resources that we need to run Kubernetes. And finally, we did an exercise for a client where we calculated how much money would have been spent if we didn't perform those changes. And we are not talking even the amount of, also the problem, some of the problem we have was with stability. The cluster didn't have any kind of problems. It was like any other business day. So that was great. But you can see by the end of the year, after the holiday season, even with Black Friday, which was totally crazy, we managed to lower the cost around 60%. And we made the numbers, and the funny thing is that year, the cost of our service with all these savings was completely free to our clients. Okay, so to finish this up, if you have to have 3 takeaways from this season, from this session, I would say that, again, run cloud native applications. That will give you most of the flexibility that you need. There are moments when you need to run other kind of applications, legacy applications, monolith applications, and it's fine. But just be mindful that it's going to be a lot more expensive, and you should make the numbers to understand if it's cheaper to run the workloads like that, or think about doing a refactor of that application or that workload and be able to leverage all the advantages that you have in the cloud. For you to have an idea, we many times over recommended our own clients to not to bother to refactor applications and run it as they are on the cloud, even if they are monolithic. So again, also processes and good practices. You will save a lot of money by working right. And if someone tells you that by following processes, you're going to be slower, you're not going to be fast, you're not going to be agile, that person needs to be re-educated. And finally, elastic infrastructure. The biggest advantage of cloud infrastructure is that you run cloud native apps in elastic infrastructure and you only run the infrastructure you need for that moment. Q&A. That QR doesn't work. I forgot to change it. So pretend that it's
Catch a
not there.
break, Luis. Catch a break. Come on.
I need, yeah.
Drink
Oh
some
my
water.
goodness. Yes.
Thank you very much. It was I have like 25 questions to ask you, honestly, but we're
What?
running. Yeah, no, myself.
All
And
right,
I'm
all right.
thinking I want to get you back to the automation topic, but we
Okay.
have exceeded completely the time. We have 2 questions on the board, so let's do something. Let's just answer those 2 questions
All
and
right.
finish the session, okay?
Okay.
All right. So the first question is, considering that shift and lift is so problematic, why do you think it's so popular? I have several ideas in mind, but you are the expert.
Yeah. Well, it's pretty easy, and that's a problem. Many vendors choose the easy path, and it's very sad to see that because we many times over get hard to fix those lift and shift deployments. It's easy. It's easy money. It's very hard to get a lift and shift project wrong. So it has a lot of success rates, right? So that's the reason it's easy and it's no brainer for the vendors. It's not so good for the clients, but anyway, yeah, that's the reason.
Good. Okay. Thank you, Luis. Let's go to the next one. It's clear that spots instances are cheaper,
Yes.
but aren't they dangerous for business?
No, they are not. Because you have to be you have to be very mindful on where to use it. If you're going to use spot instances in a database cluster, well, let me put it this way: you are not very smart because most of the time you're going to have instances rebuilding the database. But if you use the spot instances with your right bet in the right moment, in the right place, you can save a lot of money. For example, if you use spot instances to process web requests or some workload that can be cut at any minute, because you can save a lot of money. Yes, especially when you use it to process things.
Awesome. Thank you. Okay, and it was going to be only 2, but let's do the last one, okay?
All right.
And this is the last one. Don't type any more questions, people, please. Are
All
these
right.
recommendations compatible with highly resources demanding applications such as artificial intelligence, data science, advanced analytics? Yeah, I'm imagining,
Yes.
you know, a lot of computing
Yes.
usage.
Yes. In fact, one of our biggest client is an AI shop, and we use many of these things or many of these techniques to help them spend a lot less money than otherwise they would. Yeah, totally. All the recommendations, especially the last 3, or the in AI, what happens is that many times over, what you need to do is to process a lot of data, and being very smart where you ingest that data into the AI cluster is very important. How you generate the data and how you ingest it. If you generate the data that you're going to use to train your model inside or from another AWS cluster or any other cloud vendor, it's better to try to do a VPC peering and move that information there. You're going to save a lot of money. Totally.
Awesome. Luis, thank you very much to all our attendees.
It was
Thank
my
you very
pleasure.
much as well. And the
No, thank you
ATCC
to
and
ATCC. Yeah, yeah.
yeah,
I want to thank my team again, not because you have no idea how many meetings I have with my senior staff and my lead engineers, because I did double, triple checking of all facts and getting them to brainstorm with me what would be a good thing to do. So I want to thank, besides the Argentina-Texas chamber, my team, because they are fantastic.
if you allow me to say, I think you can make also white paper on this presentation after what I
All
saw how
right.
was the structure. Yeah, I think it's worthly.
Oh,
So
thank you. That's a very good idea.
to all our attendees, please, if you have anything, any topic on your mind that you want to refresh, you can see it on the YouTube channel. But I encourage you to contact Luis and Schub, that they will gladly answer
Yeah,
your questions.
yeah, totally, totally. We always love to talk about what we do. We are very passionate. We are nerds, so yeah. The problem is for us to get us to stop talking about what we do.
Yeah, I
That's a
I
problem.
know. I know.
Yeah.
My wife suffers the same problem with me and my son.
Yes,
Okay,
yes. Okay.
everyone, has
Thank
been a
you.
pleasure. Thank you very much. See you in the next webinar.
Bye.
Bye-bye.